Good evening, everybody, and welcome to the Construction Club Cost Estimating Combined session. And we are thankful that Marty McIntyre came all the way from Chicago via St. Louis to come be with us. And Mark came all the way from Fishers, north of Indianapolis, in Indiana.
So what I do is really on the marketing side. I spend all of my time talking to people about how to design with the product, how to use the product, where it might work better than other places. What I don't talk about too much, I'm sorry to say, is the price, because the Justice Department doesn't like trade associations to talk about price, but Mark can talk to you a little bit more about price. He is one of my representatives from one of my member companies. I have 10 precast prestressed concrete producers in the Illinois and Wisconsin region, and they have 13 different plants who manufacture bridge components, wall panels, architectural precast, so any of the very large structural type pieces of precast concrete that you would see. So you visited County Materials, or many of you, I guess, visited County Materials and got to see the bridge side of things. Mark's company does architectural precast, and so what they do really is what you see, cladding a building and the exterior of those types of structures. Do you want to say anything else about High?
Yeah, Marty. Thank you. I should probably get out of the corner here, shouldn't I? Yeah, as Marty said, High Concrete is a member of PCI. We've been a member for quite a while. High has a number of different plant companies. They're actually headquartered in Lancaster, Pennsylvania, over near Philadelphia area, and they have plants in Denver, Pennsylvania, Lancaster area, Buena, New Jersey. The plants I work out of primarily in Fishers, Indiana, is just north of Indianapolis. So I'm a sales and marketing type, and I kind of cover the Indiana area, Illinois, south of Chicago, over to St. Louis, and down into western Kentucky. So I cover a fair amount of ground. But the company, the plants that I work out of, primarily architectural. We do have a plant in Paxton, Illinois, kind of just up the road here a little bit. Maybe some of you have driven by that or seen that. It's currently not operating right now because of the economic situation. We're a little bit slow, and we've actually kind of consolidated our Midwest operations in a plant in Springboro, Ohio, which is just south of Dayton, Ohio. But again, primarily architectural. Love to answer some questions about that. Marty's program is going to have a little bit, kind of give you a little bit of a flavor for precast prestressed concrete in a number of different areas, a number of different type of product areas. You know, I'd love to comment more a little bit with you on architectural. And maybe when we're done, we can finish up with a question and answer, tell you a little bit about my background, talk about some of the other things that were discussed, maybe cost estimating, how we get involved in these projects, working with and I call on everybody from construction managers to general contractors to architects to developers. So I see a lot of different types of things. A lot of people have a lot of different concerns, and maybe we can address some of that as well. So glad to be here with you tonight.
All right. So what I'm going to do is start by talking about some of the really cool things that you can do with precast concrete. And very scientifically, I picked 7 of my favorite projects, and I'm calling them the 7 wonders of the precast world. And they're either wonderful to me because of the beauty of the product, or just the technology of the product and their ability to do some things with the engineering and the way that they've put the pieces together. This is called the Baha'i Temple. It's up in Wilmette, just on the north shore of Chicago, and it was built started in the early 1920s, and it finished with the precast portion of it 1934, although it wasn't completed until 1950. So I don't know that any of you will probably work on a project that will take quite that long to complete. But this is when precast concrete was really in its infancy. And, you know, as an industry, we think of ourselves as being about 50 years old. And so this was even really before there was a precast industry. But the precaster was actually out of New York. And he created all of these forms first out of plaster, and had somebody come in and sculpt all those plaster pieces, and then they placed the concrete over that, and it mirrored the plaster pieces, and they created this beautiful temple with a lot of architectural detail on it. Not quite as beautiful, but I think still quite a wonderful project is the Channel. Just the technology that allows us to go underneath the ocean and connect England to France. They actually used two different types of precast pieces on the Channel. So on the French side, they used one type of piece, and on the English side, they used another. But they were both connected pieces. They just have tunnel lining components that were then grouted and bolted into place. And takes you through. This gives you kind of a really nice idea of all of the different pieces that created the Channel. The Sunshine Skyway Bridge is in Tampa, and that is a 5.5 mile long bridge. And again, it uses this cable stay main section, and then it also has segmental pieces of precast that are then connected together. And it remains one of the longest segmental precast bridges out there. And I love this project for two reasons. One is the technology that allowed them to do it, and that it's such a wonderful engineering feat. And the second reason I love it is it's a beautiful structure. So there was a lot of beauty that went into it as well. And they were replacing an existing bridge. This is a project in Rome called the Jubilee Church. And I was actually showing this to some students on Monday night, and they said, oh, we just went to Rome last semester and went to visit this church. And they said that the pictures don't even begin to do it justice. But there's a couple things that are really remarkable about this project. One is the shape of the architectural precast. Most of the time when you think about concrete walls, you're thinking really in terms of very straight lines. But with architectural precast, you really start to have that ability to take on different shapes and different looks to the structure. The other thing about this is that Richard Meyer, who's an American architect who designed this, really loves two things. He loves the bright white that you can get, and he loves to design white buildings and thinks that they bring a lot to his designs. And then he loves to bring light into his structures. And he managed to do that by, again, having that very reflective white material. They used white cement, but then they also used an admixture in this that is a carbon dioxide inhibitor. So it's a self-cleaning concrete that actually takes carbon dioxide from the air and is also a cleaner way of building. Very similar in some ways, but a little earlier project is the Sydney Opera House. And this was designed in the early 1960s by a Danish architect called Jorn Utzon. And when he designed it, the technology was not available to actually build it. So it took them so long to figure out how they were actually going to build it. And what actually happened was he finally had this brainstorm that if he repeated the same radius for all of those different stems of the seashell kind of, he would be able to do it out of precast concrete. And it's actually one of the earliest examples of a building that used computer-aided design. Very rudimentary computer-aided design, but one of the first projects. But when you start to read about this project, you can't believe that nobody's made a movie out of the making of the building of the Sydney Opera House. There was so much intrigue, and the architect ended up getting fired before the project was finished, and then he never actually saw the finished project. He was so bitter about it. But it's still, to me, just a remarkable engineering feat, and also, again, just the beauty of the product. Transamerica Tower, built about the same time. What makes this really interesting is that it's built in San Francisco, so that's a high seismic area, and that's one of the areas that as an industry are really studying all of the connections. How do the precast pieces connect together, and then how are they going to respond in a seismic event? So we've just done some research with the University of California at Davis and a few other universities, where they did a full-scale building with a shake table test, where they replicated the Loma Prieta earthquake to see how the precast would function in that. And so this is a nice early example of taking precast up high on a structure. This is actually a project that Mark's company worked on, called COSI, the Center of Science and Industry in Columbus, Ohio. Do you know anything about this? You want to?
Yeah, thank you, Marty. Yeah, this particular project had some big challenges to it. The Japanese architect, Harada Azazaki, he wanted basically very tall panels that kind of swept back toward the top of the structure itself, which made them very difficult to form and very difficult to transport. So we had to build special forms, and actually, since the panels didn't lay flat, we actually had to brace them on the back of trucks because of that sweeping arch near the roof of the. Oh, okay. Thanks, Marty. These are some of the forms that we were dealing with, as you can see, and this is actually the bracing of the panels when they were going to ship them to the job site itself. From the standpoint of the joints, the other unusual feature of this particular job is typically precast panel joints they're flat and they're caulked with a piece of foam backer rod, and we put the caulking material over it. The architect was very concerned about those joints and what that was going to look like, so they actually came up with a stainless steel. It's kind of difficult to see in this picture, but it's actually a kind of a rounded bullnose shape, but a stainless steel feature that actually was put into those panels between the joints to again kind of give it a different look. On the ends of the building, go back to the last slide, Marty. We actually had a very, again, difficult condition here, kind of like a colothoid type curve. You had actually sweeping upward back toward the roof and actually radius and curving around on the ends of the panels as well. So again, a very, very challenging architectural precast project.
So that's my seventh wonder of my 7 wonders of precast. And I just think it's kind of fun when you're starting to think about a product, kind of how do you take it to the limits? What can you do with it that's a little bit different? But most of the projects that you work on, if you're working with precast concrete, you're not going to work on that. But I always think in terms of the design and construction as being kind of like making music. I'm a musician by avocation. That's my other interest. And I think that designers and contractors do a lot of things that are very similar to what musicians do. You're working within this construct. You're working within the framework of, either the white keys and the black keys and how you put those together, or you're working within what pieces of the precast you put together and how they end up looking. And as you see from the projects that we just looked at, it can look very different. They can function very differently, but they're all pretty similar products. And I always like to think that, either with those products, you're either doing something like Handle or you're doing Metallica, but you're still working within that same idea. So what are the different products? Well, this is a little animation that shows you all of the different precast products that you can use in precast structure and frame building. So you start out with the interior wall panels and columns and beams, and you can actually even use precast stairs. In this building, they have spandrel panels that are also functioning as part of the structure, because then you're going to have your double T's rest on there. You can see you've got the spandrel panel, and then they've got corbels coming off of there, and the stems of the double T's are then going to rest on those corbels. So there's different ways of doing that. Sometimes you can do the same idea with hollow core floors, where you might have a shelf that you create to put that together. But this just shows you how all of the different pieces of precast fit together. and then you can have an entire precast structure or frame. You know, our industry would love it if every building used this kind of structural system, but you know, more often than not, we're working within you know, the best practices for that building. So you're maybe putting architectural precast on a steel structure or a cast in place structure. Sometimes it's on a precast structure like this, but this at least gives you an idea of what some of the different products are that come together. And there you've got your HVAC. It's hanging off the bottom of the double T's. And then you come out, put the windows in. So 3 minutes you can put up a building. That's one of the great things about precast. Maybe a little slower than that, but it is something that you can you can build with it pretty quickly, and you don't have to have a lot of things like winterization of the site. You don't have to do weatherproofing. You don't have to have a lot of materials on the site. The precast comes to the job site, gets taken off the truck, gets put right on the building. The truck drives away, and you know, that's what you have. You don't have to have a lot of scaffolding. What you really need is just that crane out on the job site. So I thought I would take you through what the different products are that we offer as an industry. Probably the most common product that you're going to see is hollow core. Hollow core comes in widths of 2 feet, 4 feet, and 8 feet. Typically spans about 30 feet, although you can span up to 50 feet with it. And you can also get floors that are anywhere from 6 inches deep to 16 inches deep. But typically they're about 12 inches deep and they span about 30 feet. So you can see they've got those holes in there. They've got the hollow cores, which is why it's called hollow core. Anybody want to take a guess as to why you put those cores in the middle of the panels? You're too juiced up on pizza to think? It's the weight. You don't need the weight of the concrete for the strength. So the precaster will take out that weight, makes it easier to ship them, and they still function very well. Double T's. All right, here's an easy question. Who can tell me why they're called double T's? That's it. Ah, all right. You guys are still awake. Yes, it looks like 2 T's next to each other. So you've got your flange across the top, and then you've got your stems coming down, and it looks like 2 T's next to each other. Those are typically going to be 12 feet wide, and they can span about 60 feet long, but you can span anywhere up to about 110 feet with them. What you do when you start getting longer pieces is you usually have a system where you put the wheels on the front, and then you almost use the double T as the truck bed, and then you put wheels on the back of it, and so you don't actually put it on a truck bed. You just transport it with the 2 wheels.
Just a quick comment is actually some things have been innovated in the industry. High Concrete in particular was one that helped innovate a 15-foot wide double T flange, and they're also working on a 16-footer. You're probably wondering, how would you ship a piece like that? It would overhang the truck, and they've actually come up with a kind of a tilt brace, if you will, that kind of tilts the T over diagonally, which allows it to go down the road. So again, that's one of the bigger innovations in the industry. What that allows you to do is have wider base spacings and eliminate more columns, and helps make for a much more efficient design in some cases.
Architectural precast, this is mostly what High does in this part of the country. And that's really all of the exterior cladding on a building, where you're starting to look at, you know, what does it look like, the color, the texture. And most of the precast that we talk about is cast in what our industry likes to call long line beds. So there's steel beds, and you'll cast products on there thousands of times. You'll make the same product over and over again. But with architectural precast, each piece is unique. It's usually cast in a very high quality wood form, and it's specifically designed and cast for a particular project. Wall panels are a little bit different than architectural precast. They're still used on the exterior system, but they're usually very flat panels. You usually stain the outside of them. So, you know, you're not as worried about the color and texture of the products. And those are cast in long line steel beds. So that's kind of the difference between wall panels and architectural precast. Structural products, then we also have products that are inverted T's, ledger beams, columns, anything that is going to support the decks and the structure of a building. Back 10 years ago when I started this job, we were doing a lot of modular construction because there was a prison market. Right now, nobody's building prisons in Illinois and Wisconsin, but the technology is there to do a 5-sided box with an empty section on the bottom, and then you stack the boxes one on top of the other, and the ceiling of the box on the bottom acts as the floor for the box on top of it. And the nice thing about these is you've got the ability to add your toilets, your beds, your safety equipment, all at the manufacturing plant instead of doing that in the field. And a lot of insurance companies right now are really pushing that idea of modular construction. They like to try to get as much of the construction happening in the controlled environment of a plant and try to keep it out of the field because it's so much safer. You guys are probably doing electrical and things like that in some of your panels. You want to talk about that?
Yeah, that's one of the nice things about precast panels, and we're seeing more of that with the type of work that we do nowadays. The architectural panels can be anything from just pure cladding panels to they can actually carry loads, building loads, floor loads, roof loads. We can actually, as Marty mentioned, we can cast electrical boxes and conduits in the back of panels. Again, that's very helpful for some industries, like prisons in some cases, or some kind of manufacturing buildings. That's also something we can do. So, again, a very versatile product from that standpoint.
Then the last product I wanted to share with you are our transportation products. And we've got arch culverts, box beams, sound walls, I-beams, ashto beams. So there's all sorts of different bridge products that are out there. In Illinois, the tollway uses about 95% of their bridges are precast, and the DOT uses about 50% of their precast for about 50% of their bridges. And you know, shorter spans, you're going to use a box beam. A real short span, you might use an arch culvert like you see here. And then these ashto beams or the I-beams, they can start, or bulb beams, they can actually go up to about 175 feet. We just had a producer on the tollway, on a tollway bridge, do bridge beams that were 175 feet long. So there are some real possibilities to get very long spans, as well as short spans that go up really quickly. So a lot of county roads and things like that want to have bridge beams that go up quickly with as little inconvenience to the public as possible. We're seeing a lot of precast used in those types of beams. Not really in our industry. Our industry really focuses on that plant production and the quality control that comes with doing the plant work. And we also have like a certification program through PCI that allows you to buy precast from a plant that's been certified as somebody who's qualified to do that. And it's a little bit harder to do that with that kind of plant. But I think that as technology changes, our industry may have to change to adapt to that kind of thing. I don't know, are you guys doing any of that?
No, typically, we're producing all our products in the plants and shipping them to the various job sites. We just feel like we can maintain better quality control by producing in the plant. We have more consistency to the batching, the mixing, the temperatures, all the things. With architectural especially, architectural precast is very, the architects have a very high demand for quality and consistency from piece to piece, from panel to panel, and they want that color and finish consistency, and the best way to do that is to do in-plant production. But it's not unusual to ship panels several hundred miles to various job sites. In fact, I picked up a job this summer that we're doing in St. Louis that we're shipping from Springboro, Ohio, over near Dayton, Ohio area. So I mean, that gives you an idea how far away we're going with these products.
So that yes.
Most of the materials that we use, and especially with architectural, but a lot of producers as well, it's very important in our operation. If you ever have an opportunity to come to the plant, if we have the Paxton plant open again, we'd love to have you, or another operation, certainly. But those forms need to be turned over every day. And as Marty pointed out, with architectural precast, a lot of the features that you see on the panels, the reveals, whether there are projecting features like bullnoses or returns, things of that nature on panels, we produce all these things in the plant, and we want to make sure that those forms are turned over every day, because we need to make new pieces to constantly keep that operation going from that standpoint. So the materials, the cements, for instance, we use are very high strength. Typically, they're high early curing cements, type 3 cements, things of that nature. The specifications call for 5,000 psi of that concrete every 28 days, and normally our strengths are fairly high like that overnight, just because we have to have enough strength in the material to be able to lift it out of the form itself, because everything with architectural, all the features are built down in the bottom of the form box. So anything you would see on the exterior of an architectural wall is built basically in the bottom of the form box that's in the plant.
You guys have any other questions about the different products that we went through? Yeah. Yeah, nobody's building any single-family residential right now, and even the other market. So, I think that there's a lot of opportunity for that. If that market should ever pick up, we'll see more of it, but we're not seeing a whole lot of it right now, because nobody's building anything, whether it be wood or precast in the single-family market. Well, single-family residential is difficult to do with precast, because you have to have a certain amount of repetition, and you have to really kind of design it within the confines, and you have so few the number of pieces for that building that it's hard to be really cost-effective for single-family. Right. Right. And Right, and we are seeing that for more of the upper end houses, kind of high end houses. The architects do like using hollow core floors over the basement for that exact reason. Because then you have this open space underneath. So if you want to put your basketball court underneath your garage, you can do that. But that's not how my house is. But some swimming pools, basketball courts, yeah, that kind of thing is what So there's a certain price point that you have to hit before I see that happening. There are communities where we're seeing some precast housing, but it's difficult to hit the price point where it's effective. I don't know. Are you guys seeing any of that?
I would agree. We don't. Our company really doesn't do as much residential type. We've done some condo buildings or things like that, but as Marty points out, one of the things that makes precast, it can be as unique as you'd like. Those forms, we can do multiple colors and finishes and clad it with brick and other things, which we can talk about more if there's some interest. But you do need to make the pieces relatively large and relatively repetitive because of the forming costs that are involved. And that's really one of the keys to keeping the product economical and making it work. And as Marty says, if you have a lot of forms to build and you can't get that repetition out of the project, it makes it a little bit tougher.
Any, No, you want to talk about the difference in a small piece versus large piece?
Yeah, thanks, Marty. In a lot of the buildings that we do, we always, when we're working with architects and contractors and engineers and trying to come up with these designs for these buildings, and I'm speaking mostly about architectural per se, but we've always found that when I talk about larger pieces, that when you take that whole elevation of the building, and if the architect is looking for some assistance in piece sizes, if you will, or doing a takeoff and design, we try to keep those pieces relatively repetitive and relatively large, somewhere in the neighborhood of 100 square feet per piece or larger. And we found that actually the more you can pump that number up a little bit, the better your cost per square foot is from an erection standpoint. Because erectors typical charge by piece, I don't know, in Chicago right now, but $2,500, $2,500 is probably not unusual. So I mean, if you can knock your double your piece size, if you will, you're going to cut down your erection cost per square foot in half. Yeah, so it's very significant. The crane doesn't care if it's picking up a 50 square foot piece or a 250 square foot piece. You still have to use the same piece of equipment to get that building erected. So why not have fewer pieces, fewer joints, and make the pieces relatively large where you can?
Yeah, I always think in terms of a column cover. So if you have a column cover and it's 1 foot by 12 feet or 20 feet, let's call it 1 foot by 10 foot, make the math easy, and then it's $2,000 to pick that up and put it on the building. Let's do the math. How much is that per square foot? It's $200 per square foot. So, if you could do if the precaster can work with the designer, so maybe you punch out the window and you have 2 column covers and the spandrels up above and below the windows, all as one piece, then you're picking up fewer pieces and the cost per square foot really starts to go down. So that's one of the areas where it really starts to make a difference in terms of the cost of the precast construction. Any other questions about the products? Or I thought I would also kind of take you through the typical places where you're going to see our products used. One are athletic facilities. I didn't really go through the riser beams and raker beams that you'll see, but we see a lot of athletic facilities, whether it be, I drove past Busch Stadium. This is a picture of Soldier Field in Chicago, Comiskey Park. So whether it be a large professional stadium or that's Milwaukee College of Engineering, their recreational facility. So we're seeing a lot of recreational facilities using precast concrete.
The athletic structures can use both structural and architectural as well. Keep grabbing. Don't mean to steal your thunder, Marty. The Indianapolis Colts, just to give you an example, just built a new stadium, the Lucas Oil Stadium. If any of you have heard about it or familiar, maybe seen it on TV. But the exterior of that building, it looks like a masonry structure or a masonry exterior, but that's actually insulated brick-clad precast panel system on that building. The architects wanted something that would erect very quickly, would have some energy conserving properties, so they wanted an insulation board to be sandwiched in between the concrete layers for efficiency. And again, it would erect very quickly and be very durable. So.
Athletic or educational facilities, a lot of K through 12 schools are starting to use precast, especially if they have to meet tight construction deadlines, and they need to build through the winter. I mentioned earlier, there's not a lot of winterization that you have to do with precast, so that can be quite helpful. You know, you don't have to get those big sheets of plastic up over the whole thing. You can pretty much put precast up all winter long. The things that are going to stop you, if it's too icy for the crane to operate, really high winds and lightning. But other than that, you can pretty much put precast up 12 months a year. And so that's one of the reasons that educational facilities really like it. They also like the, Mark was talking about the insulation. You can put insulation in the wall panels, and so you really have almost like a thermal cooler heating and cooling the whole structure. And a lot of school facilities really like that idea because they can then downsize their HVAC system, and it's going to be more cost efficient to operate that school in the long term. So a lot of them like that as well. We also see a lot of healthcare facilities, hospitals, nursing homes, anything where fire is an issue or where you want a very clean room. We do see a lot of that. I know, especially with architectural precast, we're seeing a lot of hospital construction. I looked at one of his projects today in an architecture firm I was in. Industrial facilities, anybody who travels up to Chicago, you probably see warehouse after warehouse after warehouse. And in the Chicago area, we've really perfected the art of the precast concrete warehouse. But you can have very clean facilities. If you need to have daylighting in it, you can have daylighting. These are usually driven more by price than by design. The kinds of stuff that Mark's company works on really is driven more by the design. But these are usually pretty simple boxes that the cost is really going to be the key factor. A lot of municipal buildings. I laugh. People keep asking me, like, what are your members building these days? And everybody's building water treatment facilities. So that's the big hot market right now, other than healthcare. But also courthouses, libraries, any kind of municipal building. We're seeing a lot of those as well. Offices. A lot of architectural precast goes on offices, but again, you can use that entire precast structure and frame. This is actually the FBI building in Chicago. Do you know much about that building? That's one of his projects, but it's in Chicago. So, that kind of brings to mind one of the other things that our institute has been doing a lot of research on is blast-resistant design. And we're working with the U.S. Air Force right now to create panels and connection details that are very resistant to blast. And so sometime in 2010, we should see a study come out that shows how to improve blast resistance. And here's your residential, but most of it is going to be multifamily. Hollow core is the big thing in multifamily, but we do see a lot of like these units right here that even has precast demising walls in between the units, the floors, so it's the whole thing is done out of precast. And then transportation, again, a lot of bridges. being done, whether they be here's the Des Plaines River Bridge over I-355, and that's where we had 170-foot long spans. They were done in Dwight, Illinois, or a plant near Dwight, Illinois, and went right up 55, but pretty intensely large beams. I think they're 86 inches tall and then 175 feet long. And then parking decks. Parking decks are kind of your standard product that you're going to see done in precast concrete. You got your double T beams, your spandrel panels, and what we're starting to see more and more is mixed use facilities, and also facilities where they're incorporating the thin brick, or they're really starting to make them far more attractive than they were. You know, back in the 80s and the 70s, parking became kind of an afterthought, where it was this, you know, gray box that sat next to whatever the real project was. But that's not originally how parking decks were thought of, and now we're kind of coming back around and seeing parking is included as part of the project and part of the community, and really takes on that look of the community.
I think that picture on the right, Marty, is that the University of Illinois?
Yeah, that's
Okay, that's, if any of you've seen that, that's actually a job that we did at our Paxton, Illinois facility. And I'd just like to reiterate what Marty said. From my perspective, as a sales and marketing type, we're seeing a lot more interest from contractors, architects, looking at parking. Parking garages used to be just a place to shove cars in, and they kind of, you know, they weren't very pretty. They were kind of structural, kind of ugly things next to the building. But a lot of these designers now and architects are putting these garages next to these buildings of theirs, or in very prominent locations. So they actually want them to be more architecturally like the buildings that they're next to. So they're being more demanding with the exterior finishes, maybe having multiple colors and textures, maybe thin brick cladding like you see in the garage here. But there's a lot more interest in creating those designs. Yes. Oh, they did. Okay. So you got to see those. Yeah. Yeah, that's interesting.
So that's kind of, you know, typical projects. I've got a little video that I wanted to show you. Hopefully the sound will work on this. Let's find out. That shows you kind of the typical construction. If not, we can just talk about it a little bit. I'm not sure if the sound is going to work. Yeah. It's yeah. I think that it's only getting sound from my computer. Now I've lost my. This is. See, it's on my computer. It's not on that computer. Yeah. All right. Well, we can talk a little bit about it. But this shows you at least what a precast plant looks like. These are all double T's being done. Just to give you an idea of what a precast plant looks like. And this is a double T plant. But there are other types of plants available that do architectural and things like that.
This is showing outdoor casting with architectural. Typically, we're pouring everything inside. It's a little bit different.
Yeah. So, well, without the sound, I'm not going to spend too much time on that. So, oops. It's all double T. It's like a virtual tour of that. Okay. All right.
So long beds that Marty was talking about. You run these long double T pieces, run your pre-stressing cables and so forth that I think Dr. Wabbing had shown you, or you had seen maybe at the county what was the name of the company you went to?
County Materials.
County Materials. But they'll run the cables down the legs of the double T pieces there, as you can see in the forms, and then they'll pour the material in there, finish the top flange and put the mesh in the top, and then actually they'll be able to create different piece lengths from those forms, which they use over and over again. They said strip those panels out, clean them up, and use them over and over again.
Okay. So, what happens with the double T's in any kind of pre-stressed product is they do start with these wire pieces or steel pieces that are called 7-wire strands. And they've got one piece of strand going through the middle and then 6 pieces of strand wrapped around that. And concrete is great in compression, but it's weak in tension, and that's why you add this. You add your tension with your pre-stressing strands. You start with a form like this. You put your strand in there, and then you're going to stretch it at strengths of 40 or 50,000 psi. Then you're going to place your concrete in there, and this is going to stretch like a steel rubber band. And you place your concrete in the form. The concrete is going to cure around the strand that's being stressed. The next morning, they're going to have the concrete all cured, usually a minimum strength of 3,500 psi overnight. And then they're going to come in, break their cylinders, make sure that everything's working the way it should, and then they'll cut both ends of the strand. Well, the strand is functioning like a steel rubber band, but it's been captured by that concrete. So when they cut the two ends of it, it wants to snap back together. And so now you have a piece of concrete that's good in tension as well as being good in compression. So some of the things that start to make a big difference in the cost of doing precast, the two things that make the biggest difference really rely on the architect to design pieces that are large pieces, as large as you can get, and still be able to get them to the plant or to the job site, because of the construction issues that we talked about before with the crane and all the shipping that goes in. And then the other thing that really starts to make a difference is I am completely blanking on my two things that make the repetition. Sorry, I had a senior moment there. It's past my bedtime, I guess. The repetition, especially with architectural panels where they're building very complex form, and the more complex that form is, the more expensive it's going to be. So you want to be able to use it over and over and over again, so you can amortize the cost of that form over the cost of the project. So those are the two biggest issues in terms of how much does precast cost to construct. Do you want to add anything else about maybe the process of estimating?
Well, I'll talk a little bit about it. Some companies, the salespeople get directly involved in the estimating process, actually do the takeoffs of the drawings and so forth. In our company, we don't do things quite that way. We kind of work with an estimating group. So I guess in terms of the way we work at my company, we go out and help develop the work with the architects, the engineers, contractors, and so forth, or if their jobs to bid, we get the plans, bring them in from that standpoint, and they go to our estimating department. And typically, they'll take off the building, panelize the job. It's very rare for us to actually get panelized drawings from a firm anymore. Most of the time, they give us the ability to panelize the job as repetitively and make as large pieces as physically possible that we can handle, basically, from that standpoint. We actually then work with the architect, if it's not already specified, to come up with the mix and finish for the precast itself, the colors, whether it's a single mix and color, multiple mixes, if it's going to have maybe thin brick cast into the face. We'll get all that information from the architect or from the specification, or help develop that specification, get that information to the cost estimating folks, and they basically take off the job, have it reviewed by our production department for a number of forms, repetition, that type of thing, our engineering department for making connections. And again, I'm oversimplifying it, but that's basically the process that we go through in each job. We look at each particular project, gather the information, and basically do the takeoff if the job's not already panelized, put the costs to it, and then the job will either be priced to a particular contractor or go out to bid.
So the question that I always get is, you know, how much does precast concrete cost, or how much does a wall panel cost? And there's never an answer for that, because it's going to depend so much on, oh, sorry, I keep forgetting. It's going to depend so much on, you know, what does it look like, how much repetition, how many pieces are there, what is the job site like, how far is the job site from the plant, and how much are our shipping costs going to cost. So there's never a flat answer that you can get precast concrete for X amount of dollars, because every product is made specifically for that project, and the engineering is done specifically for that project, and you know, it just depends on how far it is from the plant and all of those other issues.
Yeah, as Marty says, there's a lot of things that go into our cost structures. We look at the erection, and we talked about earlier the size of crane. What's the access to the job site? Is it can you get around it? Can you get a crane around the job site? Is it hilly? Can we only sit in one corner of the job site because of the fact that the terrain is so rough and so uneven that we can't get the crane all the way around it? That's one thing that we have to consider. The connections, the forming, how repetitive is the job itself? The mix and finish, is it one mix, relatively simple flat panels? Do we have returns on the panels? Do we have radius shapes? Do we have issues like the co-side job that we showed you? They had the sweeping kind of radius at the top, and we have to have special shipping frames for it. So as Marty pointed out, everything is kind of unique and different. Some jobs will fall within a certain cost parameter, and what we usually do is talk to customers, contractors, architects in terms of how much per square foot. And we can actually do this in two different ways. Sometimes we can look at a job and do a very quick analysis and come up with a rough square foot number, so many dollars per square foot installed. Or if we actually have the time, we can do a physical takeoff and calculate the number of square footage of the material itself, the number of pieces, that type of thing, and come up with a square footage cost for the customer. But there is going to be a specific range typically, and it kind of depends on a lot of those factors. Yes. Our company currently we use software called, I believe it's called Bid to Win, is what our company uses. There are others that are out in the market that various people use for taking off the job itself, but I think that's what they use right now. Well, typically we would go in our company. There's a training process that you go through, learning the system, the nomenclature for the estimating department, learning the software, that type of thing. But I'm sure any kind of a background that you would have in working with a certain type of takeoff software would probably help you to a great degree. Excuse me.
Oh, well, no, you pull the strand, okay. And yeah.
So we call it strand, not rebar.
Right, right. And the difference is that it has that ability to stretch and give much more so, and it's got the 7 wires, whereas rebar is just one piece. I don't know technologically. Yeah, I know that they look a lot different.
Depending on the end use of the product itself, I'm going to speak strictly for architectural, because it's obviously what I do most of it. For instance, we'll consider is the panel just a typical facade panel. If it's just, let's say, cladding a building, hanging onto a structural frame with precast steel, we might just conventionally reinforce that. So we'll just take just pre-stress the panel, as Marty was showing there. We'll put a cable through the form box and actually pull that cable through, so it's actually going to carry more load. It's going to handle that compression much better. Or we've actually, in some cases, our company does a lot of post-tension, where we'll actually, after the panels are made, we'll actually we'll cast them with the cable in it. We'll take that same cable and they have a greased sleeve that they run that cable around like a hose, if you will. And they'll actually pull that and put tension on that after the piece is made, and then cut it and do a post-tension operation, which again actually helps in some cases in a very long panel or very difficult shape. It actually helps to split that panel out and form without any issues with cracking or things of that nature. So that's the most stress that the panel is going to undergo. Typically, when it's first cast, the next morning we have to be very careful as we put that out of the form, even though it's fairly cured and it's fairly hard from the standpoint of compression and the brake cylinders, as Marty says, test for concrete strength. But we still have to be fairly careful about how we let that piece out so we handle it properly. When do we take it to the next step? That's a good question. Normally with architectural, you can erect the panels quicker than we can make them. We might, if you come to the plan, or maybe somebody that were up there, just saw that.
Oh, I'm sorry.
We're running several jobs through our plan at the same time. We might be in the middle of one job, starting one job, finishing a job. So we might be running 2, 3, 4, 5, 6 different jobs in the plant at the same time. Normally, we're going to produce pretty much every panel for a particular job, and we actually then store them out in our finishing yard, which is outside the plant, basically. And they're going to sit in that yard and wait until they're actually ready to be erected. And then we basically start shipping those panels to the job site. Because if you start it too soon, they can typically erect the panels much quicker than we can make them. Yeah. In Florida?
I have a counterpart in Florida who, there's one of me down there. Oh, sorry. I have a counterpart in Florida named Joe Lord, and so he can get you up to speed on all of the plants in Florida. Yes. Mm-hmm. Sure. I don't know if codes would allow you to still do that.
These are standard panels? Okay. I just haven't experienced any of that. I mean, just about everything, I've been doing this almost 17 years, and just about everything we do it makes it actually kind of fun from my standpoint, because every job is different and unique. The colors, the shapes, the design of the building, working with the architects. Only rarely do you get in a situation where maybe we're in an office park. And Marty said, for instance, we do a lot of precast office buildings, our company, for architectural. A lot of developers like it because it erects very quickly, looks very good, it's very low maintenance from that standpoint. But you might have a mirror image building. So maybe they're doing a complex where they have building A, B, and C, and they're all the same. And maybe we do building A and B one year, and then 2 years later they do a building C, which is exactly the same. And that would be the only case. But even in that case, we would build new forms all over again for those pieces. We wouldn't really have any stock pieces, because the architects always want to have some subtle design changes, and they want that shape and color and texture to be unique for every job that they do.
Well, I'm going to ask Marty, please, to show us a very nice piece of technology. How do they push or pull this from one side and the other side without keeping it? I guess we have here a piece.
Ah.
Yes. If you please show
That's
us
what.
this, and we'll pass it around so that you see how
Okay.
simple.
This is called a strand chuck.
This is very simple technology, but to arrive at it, to it, it's very difficult. And now you look at it.
Oh, I can't get the piece out. There it goes. It's sorry, it's kind of like a Chinese finger trap, and the strand chuck goes in there. Sorry, I can't. Oh, talk loud. So that'll get there. So this is where the ends hold the precast in place. So past that, the strand chuck holds the strands in place after they have pulled it.
I'll pass this around.
Trust it.
To touch this side or that side very gently without cutting yourself, but just to get the feel off. Okay? Don't cut yourself. I don't want to see you cut. Hold the 7 there.
Is there anything else you needed to know about precast concrete while I'm here? Okay. All right. Thanks for having us in.
If any of you are interested specifically in architectural precast, or you want, this is a kind of one of our latest company brochures. Just gives you an idea of some building facades, close-up pictures of some different types of finishes and colors, and I have some business cards here as well if ever I can help you with anything. So.
And also you can check out our website, pci-iw.org.
PCI-IW.org.
Yep.
Thanks for letting us be here.
Thank you for coming.
Nice to see you.